Welcome to my channel. This is lecture number 2, that is the Knoevenagel condensation reaction. I hope you have seen my first lecture, that is the aldol condensation reaction. So basically students, in my first lecture I am dealing with the name reaction, and that I am going to continue with the second lecture and so on. Already I have given the list of those name reactions which I am going to deal with, and all are the enolate ion reactions. So this is lecture number 2, Knoevenagel condensation reaction. We will see this reaction in detail along with its mechanism. Students, now let us start with the Knoevenagel condensation reaction. See, in this Knoevenagel condensation reaction, the substrate that we will use, the substrate that is the aldehyde or ketone or else carbonyl group containing compounds. So students, this is the substrate that we have to use for this Knoevenagel condensation reaction. Right, that we can choose any aldehyde, whether it is the aromatic or the aliphatic, or any ketone or any carbonyl group containing compounds. Right, now let us see the definition of it. See, in this Knoevenagel condensation reaction, it is a reaction in which aldehyde or ketone or carbonyl group containing compounds reacts with the compound containing active methylene group. Active methylene group in the presence of a strong base. In the presence active methylene group in the presence of a strong base, followed by hydrolysis and heat to give alpha beta unsaturated carbonyl compounds. So basically in this reaction, in which the aldehyde, ketones or any carbonyl containing compounds, it will react with the compound containing what? Active methylene group in the presence of a strong base, followed by the hydrolysis and heat to give alpha beta unsaturated carbonyl compound. So this is the Knoevenagel condensation reaction, student. Now we will see the let us come with the further reaction of it. Now before coming to this reaction, just let us summarize this, that the substrate what is needed for this Knoevenagel condensation reaction, that is that you can take any aldehyde, you can take any ketone or you can take any carbonyl group containing compounds, right? And what is this reaction all about? It is a reaction in which the aldehyde, ketones or the carbonyl group containing compounds reacts with the compound containing the active methylene group in the presence of a strong base, followed by the hydrolysis and heat to give the alpha beta unsaturated carbonyl compound. Right, now let us see the reaction of it, what actually the Knoevenagel condensation reaction is. Now we have to take any aldehyde, right? Now I am choosing here, I am taking the aromatic aldehyde, that is the benzaldehyde. It will react with what? Compound containing active methylene group. Now I will choose CH2, CH3, CH3. Now the name of this compound is malonic ester. The name of this compound is malonic ester. Now this malonic ester, this is the active methylene group. This is the methylene group, and the two hydrogens of this methylene group that can be easily replaced. Okay. Now this is the malonic ester that contains the active methylene group, and this is the benzaldehyde we have taken. This is the benzaldehyde. In the presence of what? In the presence of a strong base. Now for the strong base, if I will take CH3CONA, that is the sodium methoxide, right? CH3ONA, right? I am taking CH3ONA, that is the sodium methoxide, which can be dissociated into what? CH3O minus Na plus. It will give you what? It will give you the compound that is CH double bond CH COOH, right? And the name of this compound is what? You know, this is the alpha and the beta carbon, so there is the alpha beta unsaturation. What is the product? It is the alpha beta unsaturated carbonyl compound. So this is the alpha position, this is the beta position. So this is the alpha and beta unsaturation is there. There is a double bond. The name of this compound is cinnamic acid. So here you can write alpha beta unsaturated carbonyl compounds. So this is the alpha beta unsaturated carbonyl compound that we have formed from this one, right? So the reaction, once again I tell you the reaction, this is the benzaldehyde, because we can take any aldehyde, whether it is the aliphatic or the aromatic aldehyde. We are reacting it with the compound containing the active methylene group. So we have chosen what? Malonic ester, because this malonic ester contains, this is CH2, this is the methylene group. So this is the active methylene group containing compound in the presence of what? In the presence of a strong base, that is the CH3ONA, that is what? Sodium methoxide, followed by what? Hydrolysis and heat. So here we will write H plus, or we will write H2O and heat to give you the alpha beta unsaturated carbonyl compound. Hope you have understood this reaction. Now we will see the mechanism of it. So student, now let us start with the mechanism of this reaction. See, in the first step, this malonic ester, it will react with this strong base. See, if you dissociate this CH3ONA, this will be CH3O minus and Na plus, right? So this will act as a strong base, and this will abstract the hydrogen from this active methylene group, right? One hydrogen can easily be replaced. So what will happen in the first step? This CH2 COOCH3, here also it is COOCH3, it will react with CH3O minus, right? Now what will happen? This CH3O minus, it will abstract one proton from it here. When it takes one proton, or we can say one hydrogen from this, it will get converted into CH. Here it will be COCH3, here it will be COOCH3, and here we will give the negative sign, right? You know how we have given this negative sign? Because one proton has been removed from here, right? And where it has gone, this has abstracted one proton from here, right? So this is what? This is the carbon ion that has been formed. You can say carbon ion that has been formed, right? Now this, in the second step, what will happen? This carbon ion, it will react with this benzaldehyde. We have one molecule of benzaldehyde. So this carbon ion, or you can say the enolate ion, this will react with this benzaldehyde. How it will react? It will react like this. It will be minus. Here it will be what? COOCH3. Here it will be COOCH3 plus benzaldehyde you have to make. This is what? C double bond O. Here you can write hydrogen, right? Now see here, this is the carbon ion. This is acting as a nucleophile. What it needs? It needs the electrophile, right? Where it can directly attack and make a bond with it. So in this molecule, this is the molecule of benzaldehyde, we can create the electrophilic site. How we will create? We will create by shifting the electron on this oxygen. Now when this electron density is shifting on this oxygen will get the negative charge, and this carbon will get the partial positive charge. Now what will happen when this bond will shift on this oxygen? This negative charge will come and it will attack here, right? Now what will be the product we will form from this? It will be like this. You can join like this. C, here will be O minus, right? Here is the hydrogen as it is. Now this CH, you can write here CH, and this COOCH3, and here it is COOCH3. Right? Now we have joined this, we have used this benzaldehyde, and this carbon ion has reacted with this to form this intermediate. Right? Now the next step, what we have to do the hydrolysis. Now hydrolysis, you can write here H plus, or you can write the H2. Right? Now when you are doing the hydrolysis, what will happen? See this CH3O, or you can say OCH3, there will be the solvent effect. Whenever we are doing the hydrolysis here, so there we will apply the solvent effect, due to which what will happen? This is the leaving group, right? CH3O, and here also CH3O. They will move out and the OH will take their place, right? Means this is the solvent effect, what I am talking about. So it will be what? And this OH will take this two place, and one H plus is there, that will be taken by this O minus, right? So in total we will get this C here OH, H, CH, here you can write COOH, here you can write COOH. Understood, students? Now here in the last step, what is there? You have to do the heating as well, right? Now in this reaction, the heating is done for the prolonged period of time. So when you are doing the prolonged heating, you know here this is the carboxyl group. From one carboxyl group, CO2 will be removed, right? When you are removing the CO2 from here, what will happen? If I am removing the CO2, for example, the CO2 is being removed, I am showing like this. What will happen? This hydrogen will be coming here, it will be CH2. So what we will write here? This benzene ring, to it is the COH, this is H, CH2, COOH. Understood? This CH2, one hydrogen, one leftover hydrogen, because we have removed the CO2, one leftover hydrogen will come and join with this CH, right? That we are getting CH2, right? Now, in the last step, what will happen? There will be the dehydration. Dehydration means the removal of water molecule. Whenever you have a system like the alcohol, easily you can remove the water molecule from it. So there will be a removal of water molecule, because heating is prolonged, as I told you, heating is there. So in the heating, alcohol will dehydrate itself, means there will be a removal of water molecule to give the product. So from where you can remove the water molecule? OH is here and one hydrogen from here. Means this is the alpha carbon, this is the beta carbon. From beta carbon you have to remove this OH, and from the alpha carbon one H will be out. Means H and OH means in total water molecule has been removed. So here the final product will be like this. CH double bond CH COOH. Now see student, this is the final product what we are getting. This is the final product. This is the final product what we are getting. Already we have written this reaction, right? So this is what we have got in the mechanism as well. So very simple mechanism, students. Just you need to focus on the following step what I am telling you. See, in the first step you need to react with a strong base. When you are reacting this malonic ester with a strong base, it will abstract one hydrogen in the form of a proton. You will generate the carbon ion over here. That is a negative charge. Now this carbon ion will react with the molecule of benzaldehyde, and it will give you this intermediate that is known as what? Oxonium ion. Now again hydrolysis will be done. When you are doing the hydrolysis, we will apply the solvent effect. We will remove both OCH3 and replace it with what? OH group, right? So that is being converted. This converted into what? COOH, and here also COOH, right? Now when you are applying the heat, there will be a removal of CO2. You can write here CO2. Removal of CO2. Now when you are removing from here CO2 or you are removing from here CO2, that makes no difference about it, right? So I am removing it from here CO2. One hydrogen will be taken by this CH. So that is what I have written. Now this is the alcohol you have got. Now this alcohol will undergo the dehydration in the presence of heat. Now this dehydration will give you the, it will remove the H from the alpha position, and from the beta position OH will be removed. Means in total water molecule will be removed to get the final product. And this is what? This is the cinnamic acid. The name of this compound is cinnamic acid, or in general you can say alpha beta unsaturated acid. Okay, this is what alpha beta unsaturated acid. Here also I have written carbonyl compound. You can write alpha beta unsaturated acid. Right? Now in this step, there you can write the formation because one hydrogen has been taken by this. So as a byproduct you can write CH3OH. That is a methanol. Right? So this is the byproduct. So I hope you have understood this, the complete mechanism of it. So this is a simple, this is the Knoevenagel condensation reaction, and this is also the name reaction that comes under the enolate reactions. Hope you like this lecture and understood it completely. So in the next lecture I will come with one more name reaction. So till then, thank you.